Hello, everyone. A very good morning. Dear authors and invited guests, welcome to Technical Session 8A, 8D. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the ninth International Conference on Smart Trends in Computing and Communications held in Pune, India. The ninth edition of the conference has been organized in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event is being held through Zoom on the 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. It's another request to everyone that please stay connected with us to the closing remarks. If you have any query or update, then you can write it to me in the chat box. So before we start the session, I'd like to introduce you all to our session chair. Dr. Preetesh Kumar Prajapati. Sir is currently working as an associate assistant professor at the KD Patel Department of IT, Gujarat. He has almost 11 years of academic experience. His research interest includes information security and data duplication. He has published over 16 papers and voluntarily served as a technical reviewer in 35 plus Scopus and Web of Science journals, conference proceeding, and book. Welcome to this session, sir.
You.
As we proceed, now we'll be proceeding with the presentation. I'd like to call Mr. Shaunak Karvi for his paper titled Bright Mind, AI Interview or Test Taker Bomb. Please can you start with your presentation, sir? I guess sir is not in the meeting. Meanwhile, we can go to the next presentation. Um, I'd like to call Ms. Bhagyashree Ma'am for her paper titled Exploring Learning Algorithm to Qualitatively Assess Medicinal Plants. Moving on next, I'd like to call Mr. Azhar Abbas for his paper titled Fraud Detection in Insurance Using ML. Sir, can you start with your presentation?
Hello, I am Arable.
Yes, sir.
Yeah.
Good morning, everyone. Thank you for joining me today. My name is Azhar Abbas, and I am honored to present our work on fraud detection in insurance using machine learning, co-authored with Dr. Farah. Let's dive into how we can combat one of the insurance industry most pressing challenges, fraudulent claims. Imagine a world where insurance fraud costs billions annually, inflating premium for honest customers and draining resources from insurers. That's our reality today. Fraudulent claims like exaggerated injuries or staggered accident are cunning, designed to mimic real ones. Traditional methods such as manual checks or rigged rules cannot keep up with evolving fraud tactics. Our solution, a driving approach powered by machine learning to stay ahead for fraudsters. What does matter? Let's put it into perspective. Insurance fraud isn't just a financial loss. It erodes trust and fairness. For every fraudulent claim paid, honest policyholder bear the cost through high premiums. Our mission build a smarter adaptive system to protect both insurers and customers. To tackle this, we set three clear goals. Accuracy. Develop a hybrid model to detect fraud with fewer errors. Balance. Address the reality of fraud cases using techniques like smart synthetics, minority oversampling techniques to ensure even rare fraud patterns are spotted. Trust. Make the model decision transparent so insurers can act with confidence. But first, let's talk about the foundation data. We use Kaggle data. We use diverse data set covering claims, policy, incidents, and demography. Reprocessing step dropped irrelevant column to focus on critical features, encoded categorical variables, for example, converting text label to number, balance the dataset using SMART to ensure the model doesn't ignore rare fraud cases. Algorithm used here are decision tree, random forest, and voting classifier. Here, what innovation meets practical. Our hybrid model uses voting classifier to aggregate prediction from decision tree, random forest, and gradient boosting. Result 89.6% accuracy on real world data set, outperforming traditional method. Think of it as fraud detection jury, where each algorithm votes ensuring balance and reliable decisions. Ensembling method techniques act like council of expert. Each model votes and disagreement are resolved through meta learning. For example, gradient boosting catches nonsense pattern while random forests provide stability. Together they reduce error by 30% compared to single model. But fraudsters are clever, so we added cutting edge tool, temporal pattern, analyze claim timeline. For example, sudden spike in claim using sequence embedding, collusion detection, uncover fraud rings with graph theory and community detection. This dual approach catches both solo fraudster and organized schemes. Let's me walk you through the system workflow. Data collection. Claims are submitted and pre-processed. Features engineering. Extract critical detail like claim amount and the claimant history. Model training. Train the model on the historical data, prediction and reporting. Flag suspicious claim and share result with users and administration. So how well does it work? Let's look at the numbers. Achieve 89.6% accuracy with balance, precision, and recall. Detected 92% of fraudulent claim, high recall, while minimizing false alarm, 90% precision. Outperform standalone models like decision trees. No innovation come without challenges. Computational cost. Advanced model needs significant resources, bias, and privacy, ensuring fairness in prediction and protecting sensitive data. Solution. Technique like federated learning and explainable AI to build trust and compliance. Where do we go from here? Real-time detection. Adapt to new fraud tactics instantly with streaming data, blockchain, secure tamper-proof record for collaborative fraud prevention, transparency, tool to explain model decision, fostering trust among insurers. In conclusion, machine learning isn't just a tool. It's game changer for insurance integrity. Our hybrid model brings accuracy, adaptability, and ethics, paving the way for fairer future. Thank you. I welcome your question and collaboration. Thank you.
Any questions from the audience? Okay. The author, I think, Abbas Zahar. Can you go to the slide which is related to objectives?
Hello.
Yeah.
Yes.
Can you go to the slide objectives?
Yes, sir. Yes, sir.
Okay. Now, how you deal with identity fraud as per your model?
Which type of identity fraud means, sir? Uh, Sir, we have used historical data for identity the fraud. For example, we have taken multiple cases that how we can detect fraud. For example, if someone has got accident and they have claimed much bigger amount for that smaller accident, then it can be identified as a fraud. For example, if 25-year man got accident uh, and he claiming much bigger amount at that accident in which previously who have claimed much smaller amount. So for that way we can detect that this is an fraud.
Okay. Have you considered the identity fraud also in your system? For example, two persons may having the same name.
Yes,
Let's say you are going to the hospital and you
yes,
can just giving the random name. They'll be in taking in as an input, or let's say inpatient kind of thing, right? So without earlier and the case of accident and other thing, generally nobody cares about the identity at the initial stages. So
yes,
for
sir.
example, I've got an accident, right? I'll be writing any random name. So how
Yes.
you're means how you are going to detect that as per your technical description?
Sir, to identify fraud insurance claim, uh, we follow a structured machine learning workflow that include data processing and feature extraction, model training, and prediction. Uh,
Okay, not an issue. One or
y-
two feedback for you. Please include the references where you are taken in the slide also and at the
oh,
end wherever it is visible. Thank
oh,
you.
yes, yes, sir, yes, sir. Thank you, sir. Thank you, sir.
Thank you, sir, for the presentation. Moving on next, I'd like to call Mr. Shaunak Karvi for his paper titled Bright Mind, AI Interview or Test Taker Bot. So please can you start with your presentation?
Hello, is my screen visible?
Yes, sir.
So, good morning to all present here. I am Shaunak Karveer, and this is our paper title, Bright Mind AI, Interview and Test Taker Bot. So, first we will look at the problem statement, then literature review, objective tech stack methodology results, and some future scope, what we are going to add. So first we go to the problem statement. While many engineering students or many college students are appearing for placements and interviews, the manual self evaluate themselves. So this can be a lot subjective if another human is evaluating himself or not. So it does not provide any objectivity to it. Evaluating results and more informed reflection about their uh, training training and preparation. So, what are our objectives in this? So, we are planning to conduct an autonomous interview and quiz with an answer comparison mechanism, topic specific question generation, real time feedback provisions, and cheating detections like it is present in various websites today. So, some references we took are uh, this is a question generation model. it is a Chinese paper. So it generates question based on the Bloom's taxonomy levels. So many of the colleges syllabuses are designed on Bloom's taxonomy. So it segregates the questions into various topics and different difficulty levels. So uh, this aligns with our project. So we have took some references from it. And the second is avatar-based feedback in job interview training. This paper states that if an aspirant wants to apply for an interview, so it creates a simulated environment for it, and from which they can gain confidence from it. So this paper also follows some mood changes and all, which we are going to improve in our future scope. And some disadvantages of this are there can be false negatives and false positives. And the future scope of it is the understanding of human computer interaction and improve avatar-based feedback mechanism. So this is another model which allows for an efficient interview taking. So this works on an XGBoost model, which works on an n-gram patterns and allowing for efficient question classification. So if the questions are classified correctly based on which can be on any parameter, which is difficulty level or the different topics, etc. So it can help the user immensely and in gaining confidence on his skills. And this is an another interview bot which uses NLP and tokenization Bayesian interface. So tokenization also helps in segregating the questions uh, in a better way. And we are using video retalking for our avatar, AI avatar generation. So it creates a superior visual quality and emotion control. So the user can have a very real life experience for experiencing the interview. So now we come to the video retalking pipeline. So the video retalking pipeline is as the image is here. So first an new file is generated, an MP4 file. Then the the input video is masked, the audio is edited, and a low resolution of the synced video is fit into the original video. And then after that, there is a post processing and refinement of the pipeline. And the final video is generated as I will show you in the results. The tech stack we have used is HTML, CSS, and React for the front end. For the back end, we have used Node.js, Flask, and Gemini, and other some we have used utilized some APIs for this full project to work. So now we come to the main workflow of the project. Our project has mainly four modules: quiz generation, interview generation, chatbot, and a gamification. So the quiz generation works based on two types: the topic and the user provided text also. So if the user provides a PDF file to it, we can also use it. First we do the quiz generation, then we display the quiz from it and match the actual answers and display the results. So this is the quiz pipeline. Then we if we go to the interview, first we will get the camera permission of the user. Then AI avatar will be generated, which would ask the questions to the users. Then there is some cheating detection mechanisms in all these, which are tab switching, and if multiple faces are detected in the camera, it will also show the error. And if there is no tab switching or no cheating, then it will display result or it will throw an error. And all this data would be stored into a database, and it would generate a performance chart for the user. So it would be helpful for him to analyze his performance based on the particular topic or based on the particular subject. And there is a chatbot. So if the user has uh, any queries or any questions of how they use the platform, he can ask the chatbot. And we have included some small gamification games, like the games which are present in various websites, like various apps like LinkedIn, etc. Some memory games, etc. And we are also so if we display the performance analysis of the user, it will help the user to gain more confidence from it. So, what is the methodology of the project? As I explained to you in the workflow, it is similar. So the system is initialized, Then the topic name and number of questions and difficulty level would be selected by the users. Then the API would be called. Then the avatar interface would be generated. And then the avatar would be, avatar is used by Make It Talk, and it would also store the user response every time. Then the quiz would be generated and the result would be evaluated, and continuous improvement to the project would be done. So here are some of the results. So this image which you'd see is our AI avatar. He would ask the questions. An example of questions which he asked the user is, what is the full form of NLP? This is the quiz UI. The quiz is also timed, so you can set the timer for it, like 15 seconds, 20 seconds from it. And there is a memory game for it. So they're moving the tiles one. So what is the future scope of it? We are planning to add multilingual support, some advanced personalization features, real-time emotion recognition to adjust the teaching style and provide personalized feedback. AR VR integration can be done. And also, we are also planning to add another model for a coding test, which would then become a full-fledged model for company or interview preparation for the users. There can also be cloud-based scalability for it, and industry. It can be also given to the industry and corporate training. So this is all. I welcome all the questions.
Any questions from the session, sir? No questions, so we can move on. Thank you for your presentation, sir.
Thank you so much.
Moving on next, I'd like to call Poonam Yadav ma'am for her paper titled MRI-based Parkinson's disease diagnosis with deep learning. Ma'am, can you please start with your presentation?
Yes, good morning to everyone.
Good morning, ma'am.
Yes, is my screen visible?
Yes.
Yes. I, Poonam Yadav, want to present my paper in front of you. My paper title is MRI-based Parkinson's disease diagnosis with deep learning. And I want to represent on the Parkinson's disease. Parkinson's disease is a neurological condition caused by the malfunction or death of brain tissue that produce dopamine. Dopamine is a chemical which is used for movement, and it is neurotransmitter that regulates the movement, and its symptoms. It impacts the substantia nigra neurons, and it's characterized by the motor and non-motor symptoms. Exact etiology of condition is unknown, but it is thought to be caused by mix of hereditary and environmental variables, and means environmental variables and genetic factors are the main factors for this disease. And with an estimation 8.5 million people worldwide predicted to have PD in 2019, it is the neurological element with the greatest rate of the growth. Detecting PD accurately remains a difficult task, so a new research uses MRI scan with AI and a machine learning algorithm or deep learning algorithm. We can recognize the Parkinson's disease. So our study's main objective to improve the identifying and diagnosing Parkinson's disease using real-time data, especially MRI scans, and focus on the enhancing image processing and feature extraction techniques using machine learning classifier. These are my literature review. In this, Magesh et al. Developed a machine learning algorithms that accurately predict Parkinson's disease using visual cues for the Parkinson progression markers initiative database. Means They use Parkinson PPMI database and use the CNN VG16 model and achieved 95.2 accuracy. And this Sormi et al. Developed the deep learning ensemble, and they use the DAT scan pictures and its accuracy in 98.84%. Besnine et al. Used the LSTM model and accuracy attained 90% accuracy in testing and 93.8 in validation and 93.75% in training. And Iqbal et al. Use MRI images as a data set and FusionNet as a framework they used, and accuracy attained 97.53 plus 0.24. And these all are my literature views, and I use the methodology in this paper. This is my methodology. MRI dataset I have used, and then after that pre-processing. In the pre-processing, I resized, grayscale, normalize intensity, and some noise will be added, and contrast enhancement, and then rotate and flip for augmentation. Then after that, I split the data into training, testing, and validation set. And I have used three models here: MobileNet V2, ResNet 50, Inception V3. And then after that, I use the evaluation matrices: accuracy, precision, and recall. This is my method. In the methodology, I have taken data sets of MRI images for normal and Parkinson patients. After that, pre-process the data, and in the pre-processed data, I have used the standardization, normalization, will add the noise, contrast enhancement, and data augmentation, which is used to improve the model performance. And after the processed data, some features extracted. This is the picture: original image, normalized intensity, added noise and contrast, enhanced, rotated image, flipped image. In the methodology, I use three models: ResNet 50, MobileNet V2, Inception V3. And these are my results. After the training the model, MobileNet V2 attained the 99% training accuracy, 94% testing accuracy, and validation accuracy 96%. And ResNet 50 have attained 76% accuracy, testing accuracy 73%, validation accuracy 72%, and Inception V3 96%, 96% testing accuracy, and validation accuracy 93%. So from these results, MobileNet V2 performed superior among three models. This is the graph which shows the model accuracy and model loss for MobileNet V2. MobileNet V2 attained 99% accuracy, and in blue line shows the training accuracy, and the orange line shows the validation accuracy. Means we can say overfitting reduced in the MobileNet V2. And this is the Inception V3 graph. Depicted depicted the model accuracy and loss. ResNet 50 depicted the ResNet 50 accuracy and loss in the graphs. So among these graphs, I show the MobileNet V2 performs superior. So this is the conclusion. The study demonstrates the potential of MobileNet V2 deep learning network for early Parkinson's disease diagnosis using MRI data, and its superior performance over ResNet 50 Inception V3 suggests it's suitable for distinguishing between PD and healthy individuals. So in future, research should focus on its performance and ethical consideration. These all are my references. Thank you.
Okay. Any questions from the audience? Okay. Can you go to the slide number? I think you have mentioned the slide number to the comparative study of three algorithms.
Okay, sir. Yes,
Okay.
sir.
Now, why your MobileNet V2 outperforms compared to other two?
Yes, sir. MobileNet V2 attained the 99% accuracy This is the graph which shows the training accuracy and validation accuracy, since slightly differences are there, and model knows uh, um, at particular point it is stable. So overfitting recovered sir here.
Okay, fine, not an issue.
Oh, okay. Sir.
Okay, thank you, ma'am, for your presentation.
Okay, sir. Okay, ma'am. Thank you so much.
Yeah, moving on next, I'd like to call Miss Nuance for her paper titled Real-Time Interaction with Machines Through Gesture and Speech Translation, a CNN and LSTM based approach. Ma'am, please can you start with your presentation? Poonam, ma'am, can you stop presenting so that the other person can present?
Gestures and speech translation. It's real world. We have
I'm sorry, ma'am, your voice is not audible, it is cracking.
the people who has struggles with speech recognition and deaf, so we have to we have to bridge the communications between the people who can hear and the hello.
Yes, ma'am, you're audible now, but
We
it
use
is cracking.
machines. Okay, ma'am. Okay. Sorry. The machine speech. In that we will dance our gestures into speech using the CNN model, and another model is speech to guess our speech to then back into text and to the sign images. So I need to the text first, and then it will speech, it will give the sound. So we will capture the live hand gestures using the webcam. We use text raster for processing those images and record all the speech or audio output. So we are using data sets from Google and ensuring that it's effectively in background and complex backgrounds. So we are using the Google data set for that. The different types of and it will show the positive results. It will give the 90%. It has the image image classification. It is more efficient working with image classification, and they work well for recognizing the human gestures and now we are using the achieving the accuracy of 94.4% on that. And cameras that can that we use the new methods to adjust to understand better how the people move and making them more accurate. So we use first it will start our sign language and then a webcam, then do the image processing and detect our hand detection. Image, but we are using the by audio for that. And then for that, we are using the data set with extract image, and for the speech to sign, it will the discussion of the paper. We're using the CNNs and it is and if users give if we have encountered that users give positive feedback on how the realistic and well time, and the gestures it is generated, it is improvements. We have the we can use the real world applications in the like apply in the mobile applications too, to give the work to enhance the to have more advanced way. So this is the testing and validation that we have tested. So this is this is the accuracy and loss graph. Here we can see that we have gained 0.95% accuracy and 0.2% loss. So we this figure, and the output that we have got is the sign for L, this is the sign for B. So when we are showing the sign images, it is showing the string of a string like A to Z. Whatever is suitable for that, then it will go to speech, it will speak. And when we are testing like AYE, just letter, so it will show back to the and use that we can add the more large scale data sets to give more accuracy instead of A to Z. And then we can use the multi-language support. And you can use the multiple language like like Hindi language, and like also we can improve the by using in such areas like robotics and VR and IoT, such kinds of things. And the last is the and where the internet is weak. So this is the all. So can you open for the questions?
No questions.
Okay. Thank you, ma'am, for your presentation.
Hello.
Yes, ma'am, you're audible. Ma'am, we cannot hear you. Can you write your message in the chat because you're not audible? Thank you for your presentation, ma'am. So moving on next, I'd like to call Mr. Varun Maniappan for his paper titled Small Language Models and Advancing Efficient Open Source Alternatives to LLMs. So can you start with your presentation, please?
Hello, am I audible?
Yes, sir.
Yeah, actually, Varun, the author that said to present, is not available. He has mailed regarding this yesterday. So I'm his
Okay.
co-author, so I'll be presenting today.
Sure, okay, sir.
Okay. So is the screen visible?
Yes.
Okay. So our topic is the paper that we are presenting today is small language models, an efficient open source alternative to long language model. It's a survey, and our paper ID is 238. So for when we come to the language models, and large language models are the foundation which based upon NLP. Large language model, as we know, like GPT-4 and Gemini, have significantly improved the generation and reasoning capabilities of the AI. And when trying to create a new LLM for ourselves, there are some few challenges related with it. These we highlighted these three, which are high computational costs, which that is they require like hundreds of GPUs, that two powerful ones with high VRAMs to train them, and also environmental concerns as these GPUs should be run in for months and months at a time. The energy and the CO2 emissions are harmful to the environment. And then with due to these LLMs being gate locked behind a paywall, they are not accessible to small organization and researchers. So when and coming to the evolution of language models, previously there were only rule-based models such as HMMs and RNNs, and these struggle with like many different uh, challenges. Few of them, few of them are they struggle with they struggle with very long context or long sequence text, and then lose context between in the middle when asked to summarize about it. And also they lacked training parallelization, that is they can be trained only in series and not like in parallel search, which is possible in LLMs. And the birth of LLM started with the paper made by Vashwani in Attention is All You Need by Google 2017, which uh, which introduced the self-attention mechanisms and which also enabled the parallel computation. So transformer process entire sequence at once. Which due to this, it makes them highly scalable in comparison to RNN and LSTMs. And while coming to the challenges of large language model, as I said before, GPT-4 requires a lot of training and like higher energy, and then the limited accessibility to researchers and other smaller companies. And so due to this, a new shift has occurred, which is the smaller language models. Smaller language models, unlike their counterpart, are very small in size, and also and also and also they can since they are smaller models, they don't need a lot of training time, and also they have faster inference, lower latency, and can be run locally without the need of any data centers. And so for to train a small language model, some few methods are there. and we have noted down these three, which are knowledge distillation, which is like transfer learning but for language models. Basically, we take the knowledge gained by the some other large language models and then try to compress those data, distill it, and then feed them into SLM in the using the concept of transfer learning. And to reduce the size of the small language models, we can either prune or quantize them. By pruning, I mean we can remove some of the weights, and then by quantization, we can round off the actual weights of the model into like 4-bit or 16-bit, thus reducing the size of the overall model. And flash attention, as I said before, is being employed in SLM also, and thus it increases the efficiency of the SLM overall. And in traditional attention mechanism, the longer the sequence, the memory usage grows quadratically. So to overcome this, there are few ways. First one is sparse attention, which uses the concept of sparse matrix, where the most entries in a matrix is 0 to reduce the complexity of the overall uh, attention mechanism. And flash attention, which uses a memory efficient recomputation technique, which will in turn reduce the VRAM usage. And then linear attention is used to process longer sequences, but it doesn't have the same complexity as traditional attention mechanism. And then to look into the flash attention in detail, normally what happens is normal traditional attention mechanism works by using the VRAM in the GPU to use the VRAM in the GPU to perform its calculation. But in flash attention, it breaks the data into chunks and then gives into the computer's like SRAM, which is the standard RAM. And then what it does is it gives these chunks to the GPU to process instead of like giving the whole data as a whole. So this reduces the computation time, thus increasing the efficiency and training time. So when we come to state space model, state space model is another state space model is another method to increase the efficiency of training and using language models, and and one of the major, like the one that's used today, is Mamba architecture. Mamba architecture is a state space model which only updates the needed weights in every like in every training loop, such that every weight doesn't need to be changed, so that uh, the only weight that affect the outcome will be changed. And this also enables higher parallel computation as opposed to the sequential computation that's offered by the previous methods. And since SLMs can be trained relatively cheap, there are many open source SLM models. Some of them are Microsoft 5.3, which is a 3.8 billion model. It's mostly defined for deploying resource constrained devices such as mobile phones and IoT devices. And MetaLlama 1 to there are different versions, like one from 1 billion to 3 billion. And this is optimized for domain specific NLP tasks, and also can offer like in a specific domain when fine tuned with the knowledge from the domain. And Google Gemma is also a model which is available in multiple sizes, and it's like a general model, and it can be used to any other proprietary large language models. And then the significance of open source AI is to overcome those challenges that we face from the closed large language models, which is to enable research and then advance AI development, reduce the cost on training, and then each organization can use it to custom data to fine tune the model to their use. And then for future directions, we can integrate like multiple architecture into one. so as to leverage strengths from both of the methods used. And then Green AI initiative is, as I said, training language models takes a lot of energy and then emission of CO2. We can implement strategies to reduce the carbon footprint of training the language models. And then SLM for domain specific is simply making a language model to fit like personalized task. Like if say we feed a SLM or fine tune SLM for finance application, it can be used to answer question from that domain more efficiently. That's my presentation of this paper. Thank you.
Okay, can you go to the slide number 5th or 6th where you are dealing with optimization and quantization? Where you have mentioned the term quantization.
Here.
Yeah, so on which basis your BMS or this particular paper is going to be remove redundant parameters? Because this is a survey, right? So you might have learned in depth kind of okay why they have selected XYZ parameters.
Sorry, can you repeat it again?
Yeah, for example, you have mentioned out of that small LLM, right?
Yeah.
Pruning and quantization, right?
Yeah.
So reduces model size by removing redundant parameters. So which are the redundant parameters?
I mean, it's the weights that are like the least affected in each iteration, which means they don't actually contribute much to the final result.
Okay, and can you what is the outcome after end of the particular review? Okay, for example, for X, Y is better. For A, B is better.
Okay. Can you repeat that again?
For example, you survey this particular SLM models, right?
Yeah.
So you might have studied, okay, for X, this Y is better, and for A, B is better. So do you have that kind of comparative table or something like that?
No, we do not.
Okay, thank you.
Thank you.
Thank you, sir, for your presentation.
Thank
Moving on next, I'd like to call Ms. Bhagyashree ma'am for her paper titled Exploring Learning Algorithms to Qualitatively Assess Medicinal Plants. Ma'am, please start with your presentation.
Yes, thank you, ma'am. Is this visible?
Yes.
Yes, ma'am.
Yeah, good morning, all. I am presenter Bhagyashree Lamture. My title is Exploring Learning Algorithm to Qualitatively Assess Medicinal Plants. So, this is agenda for today's presentation. Introduction. A medicinal plant plays the crucial role in providing raw materials for medicinal products that hold both economic as well as the medicinal value, we all know. So under that, challenges which we could face, so that will be quality evaluation of those medicinal plants, then diverse data sources. Data sources is nothing but varieties of medicinal plant, or maybe that came under the category of one plant having variations between that. So here I would like to say about the tulsi medicinal plant. Tulsi used as traditional Indian Ayurvedic medicine. So extract from that tulsi that have been used in traditional Indian Ayurvedic system. And tulsi in modern medicine, we could say the nutrition value for that or pathochemical constituent like eugenol and many more are there. Then it play role as antioxidant, antibacterial. So problem statement is to design and develop machine learning based algorithm for enhancing the quality assessment for Tulsi medicinal plant using diverse data sources. So all these are the literature review which I reviewed. After the studying all the literature paper, I found in the medicinal plant quality identification, several quality assessment feature are used to ensure the authenticity, potency for that particular plant. So the features which we could see from by our normal eyes, that the features like morphological features, so that help to examine the size, shape, color, texture, and many more external marking of that plant, such as leaves, stem, root, and flower, seeds. Then microscopic analysis, so under that, studying the internal structure including cell arrangement, or the, we can say, the extract or acidic property of that plant. Chemical composition, so the chemical testing, the reading based on the chemical testing, that is a pathochemical screening. Here we can see the tulsi having a eugenol acidic property, so that we could able to find that such a kind of absorption and spectra from the chemical testing. So here I have mentioned the analytic techniques such as TLC, or we can say HPLC, that is high performance liquid chromatography, gas chromatography is there. Spectroscopic methods are there, so UV spectra, IR spectra, that is nothing but the infraspectra spectroscopy, then an NMR and MS. Then the next, that is based on the DNA barcoding. So this is proposed methodology. So here I have collected the data set related to the tulsi plant, then I have applied the pre-processing on that, feature extracted, so that will be morphological, chemical testing, and the feature selection, and at the last I have applied here the learning algorithm to explore. So this is in detail proposed methodology. So here having the collection of medicinal plant, this is a data pre-processing, the ML and DL algorithms I have applied here, and after the applying the model, it could able to identify the healthy leaves, dried leaves, and unhealthy leaves. So all these are the steps under the proposed methodology. uh, this is all about the data set which I could apply for this proposed for this model. I have categorized the data set beyond the basil leaves, dried, healthy and unhealthy, and on that, as well as I have collected those real time data set from two different region, one from Pune and one from the Sholapur. This is my collection, data collection. So here I have collected two varieties of tulsi plant, OCM plants, that will be Radha tulsi and the Krishna tulsi. So all these are the collections. Summarization for particular my data. So Rama tulsi, that is a Osimum sanctum, that having total 75 number of images each class having, and the Krishna tulsi, that Osimum teniflor, that having the 80 number of images within each class. So after the applying CNN under the deep learning, then mobile net V2 and the dense net, I got the accuracy. So this is a result, accuracy and loss curve for the applying the after the applying the CNN model. I got this accuracy and the loss. So this blue line indicate the training accuracy, and the orange line indicate the validate accuracy, and the respective curve for the loss. Same for the mobile net and the dense net. After that, this is for the confusion matrix. So here I got the basil plant unhealthy, that having 93% accuracy. This is for mobile net confusion matrix and dense net confusion matrix. So all these are the formulas: accuracy, precision, and recall, F1 score. So yes, this is a comparative analysis for the model. So after the applying CNN model, it able to capture the accuracy at 83, for mobile net 86, and for the dense net 89. So dense net for my the collect the images which I able to could collect, as well as the open data sources for the medicinal plant. So combination of both, I will get the more accuracy for the dense net model. And at the last conclusion, to enhancing the quality evaluation methods through the advanced data analysis techniques, facilitate the comprehensive assessment and the detection of adulteration in medicinal plant, ensuring the consumer safety and the product efficiency. All these are the references. Yeah, thank you.
Yes, good work, in-depth review. Good.
Sorry.
It was good in-depth review as well as the experiment. Very good.
Yeah. Okay. Thank you.
Are you planning to extend this paper into journal also?
Yeah.
Good.
Yeah. Thank you.
Thank you for your presentation, ma'am.
Okay. May I stop sharing?
Yeah.
Yeah. Okay. Thank you.
Moving on next, I'd like to call SK Manjula ma'am for her paper titled Stock Market Prediction Using Machine Learning Models. Ma'am, please can you start with the presentation?
Oh, yes, I'm audible.
Yes, ma'am.
Okay, I'm sharing my screen now. Is my screen visible?
Yes.
Yes.
Good morning, everyone present here. Thank you, SMARTCOM, for giving us the wonderful opportunity. The topic, stock market prediction using random forest classifier, is presented by Manjula Sri and followed by co-authors Shreya, Santharuban, Anilet Bala, and Harsula Prashad. The contents are introduction to stock market, secondly the motivation, and followed by literature survey and challenges, and next comes the methodology, then simulation result and conclusion, and finally references related to our paper. Now we can see a short introduction to stock market prediction. It is the attempt to forecast the future value of company stock, like historical data, machine learning, and fundamental analysis. With the stock market inherent complexity, predicting price value movements has always been a challenge. Traditional method often falls short in capturing the vast amount of data and subtle pattern that influence the market. Machine learning, however, offers a new approach by using algorithm to analyze large data set, identify trend, and make prediction. In this presentation, we will look at how machine learning techniques like time series forecasting, sentiment analysis, and predictive modeling are being used to improve market prediction and decision making. Let's dive into the motivation, followed by our co-author Shreya. AI is revolutionary trading by providing easy access to advanced tools, making stock market investments is more efficient. Machine learning and algorithm trading enable quick data analysis and trend prediction. So in India, AI is increasing vastly, supported by SCBI, improved regulatory measures. Stock market helps business like raise funds and reflect the economic health and serving as a popular avenue for the investing in a high growth companies. Next is the literature survey. So these are the four main reference that is related to our paper. So in our paper, like we have done a three algorithms, that is random forest, SVM, and the logistic regression. Next, we'll go for the challenges in the stock market prediction. So here, like these are the 8 main challenges that I have listed here. So the first one is the market related challenges. Here, the prices fluctuated due to the global events and the investors' sentiment. Next one is the regulator challenges. So here, the rules and regulation affects the model flexibility and accuracy. Next one is the technical challenges. Here, like advanced models need high computing power and experts. Next is the data volatility. Rapid prices changes make prediction challenging. Linearity. So making a market trends are unpredictable and it is hard to model. Next one is a limited historical data. So the availability of historical data may not be sufficient for the training models, especially for the new stocks. Next one is the overfitting. Here, the models may perform well in training data but fail to generalize to unseen data. Next one is the data quality and bias. So your poor quality or biased data can lead to inaccurate prediction and model performance issues. So next we'll go for the objective. So the main objective of the stock market prediction is to predict the stock prices by analyzing the past data, detecting trends, and assessing model accuracy using statistical and the machine learning methods. Next, the followed by the Santharupan, that is methodology.
So actually, we started our process with data pre-processing to clean and prepare the data set for better analysis, which ensures the quality of our data sets. Next, we performed a correlation test to understand the relationship between the variables in the data sets. We then built and evaluated several models, including SVM, logistic regression, and random forest. Each model's performance was asserted to determine the best fit for our data set. After after selecting the best performing model, we conducted a detailed analysis and used it to prediction. In conclusion, our approach demonstrated the effectiveness of the machine learning algorithm in analyzing and predicting the outcomes from complex data sets. Uh, Through this process, we got a simulation results which surprisingly resulted in 99% for the random forest and 97 for the SVM, which is the lowest accuracy we got, and noisy and non-linear output that was given by logistic regression, which resulted in 98%. As we conclude from this, the random forest is the most effective way to train a model to predict the stock market data. To conclude our analysis, uh, provided the random forest outperformed the SVM and logistic regression, achieving the impressive accuracy of 99.64% in stock market prediction. This highlights the significant potential of machine learning in enhancing financial forecasting. Looking ahead, there is a exciting future scope for real-time model retraining and integrating sentiment analysis to further improve predictions accuracy and adaptability in dynamic market conditions. These are the 15 references that we are attached to, sir. And thank you, sir. Is there any query?
Yeah. Can you go to that objectives?
Okay, sir.
Okay. So, what's the data set you got?
Sir, again, please.
Data set we have selected either NSE or BSE.
It's a message.
You mentioned analysis of historical data, right?
Yeah, sir.
So, which kind of data you are dealing with?
So we deal with that. Huh?
Is it Indian based or across the globe?
We based on Indian only, sir.
Okay. Now go to that. I think you have mentioned the motivation kind of thing. Okay. So I think you focus on fundamental analysis also, is it?
Yes,
Yes,
sir.
sir.
Okay. So how you have incorporated that thing into that your building of the model stage in your proposed system?
Sir, actually, in investing, there are two types, sir, which is long term and prediction, sir. For long term, it's not required, sir. For
Okay.
prediction type investment, it's based on a prediction only, sir. It's like gambling only, sir. For that
Okay.
only, we are building this project, sir. So it will tell us to rather to put or call the trade, sir.
Got it. Thank you.
Thank you, sir.
So thank you for presenting us.
Okay.
Can you please repeat?
Sir, is there any query?
No. Thanks.
Thank you, sir.
Thank you for your presentation, sir. Moving on next, I'd like to call Mr. Umakant Singh for his paper titled Stock Prediction Using MLD.
Okay. My screen is visible.
Yes, sir.
Good morning, all of you.
Yeah, please, you can
Good
continue.
morning, sir.
Ma'am,
So you're audible. You can start with the presentation.
my screen is visible, ma'am?
Yes.
Okay, ma'am.
Yes, sir.
Okay. Good morning, all of you. My topic is stock market prediction using machine learning techniques. So my agenda: abstract, introduction, literature review, proposed system architecture, algorithms, experimental result, and conclusion and references. Basically, in my paper, we use two machine learning algorithms, decision tree and gradient boosted tree, and we compare the results for the both algorithms. This is a brief introduction. Basically, stock market is the activity and the business, finance business is demand is constantly growing. Stock market prediction is the process for determining the future value of the company stock. Stock price are influenced by the various factors, including the both known and unknown factors. Known factor is stock price, like opening, closing, high, low price, trading volumes, technical indicator like a moving average, some fundamental data like a P/E ratios, companies earning revenues, and unknown factors like market sentiments, geopolitical events, natural disaster like which COVID-19, which is about 20, earthquake, regulatory changes. Uh, so my proposed system is my objective is predicting stock price using a decision tree and gradient boosted tree, and we consider the features open, close, min, max, and volume. uh, for this purpose, we use the libraries for the data cleaning, NumPy and Pandas, and for the analysis, machine learning analysis, uh, um, scikit-learn, and visualization purpose, we use the matplot and seaborn. We use the 1 year Netflix stock data. Basically, we download from the Yahoo Finance websites, and my data is April 23 to April 24. Basically, we split the data in two parts: 80% for the trading purpose and 20% for the testing purpose. And feature selection, basically we focus the open price. And model, machine learning model, we use the decision tree and gradient boosted tree. Decision tree is a supervised machine learning algorithm, which is used for the classification and regression tasks. It works by the splitting data into the branches based on decision rules, making it easy to interpret and visualize. Some advantage of the decision tree to easy to understand and interpret, and it used for the both numerical and categorical data, and no need for the feature scaling like a normalization, and limitation is no prediction accuracy. Gradient boosted tree is the stable learning techniques that builds the multiple decision tree sequentially, where each new tree is corrected and errors of the previous ones. Unlike a random forest, GPT optimize the model using the gradient descent, reduce the prediction error system by step. Advantage of GPT is high accuracy, handle the both numeric and categorical data, and disadvantage is slower. Basically, we implement the both algo on on my data, and we use the we calculate the following matrices: MSE, mean square errors, Fitment score, mean absolute errors, mean absolute percentage errors, R square, RMSE, accuracy, precision recall, and F1. These are by the results. First table show the both have decision tree and gradient boosted tree, MSMAE scores, fitment scores, MAE and MAP. These are the calculated value. For this value, GPT is better in terms of the MSME, MAE, and MAPA and fitment scores. Second table, we calculate the R square errors and RMSE and accuracy. So decision tree give the R square errors is 0.99, and gradient boosted is 99, almost same. RSME value is 2.3, and gradient boosted is 2.03, and accuracy is 0.98, and gradient boosted also 0.98. And second table is precision recall and F1 scores. So basically, both model have the similar precision recall and F1 score value. Conclusion is gradient boosted tree outperform decision tree in precision and error matrices. GPT has slower MSME, RSME, and MAE, leading to more accurate precision. Decision tree are easier to interpret but less accuracy. These are the differences. Thank you, sir.
Can you go to that data set
Data set.
that you
Sir,
mentioned Netflix for 1 year?
Sir, basically I use the Netflix data set.
Okay. Okay,
Netflix,
so you
Netflix.
have got it. So try for only one Netflix stock for 1 year data only.
Yes, yes, only 1 year.
Uh, you should try for at least 8 to 10 years and go for this particular experiments. Okay, not an issue. Thank you.
Sir, what's the approx 10-year data?
Approx 8 to 10 years data. Then I think we'll be giving a better answer because this will be having only 365 entries only. And if you are excluding that holidays and other things, so roughly you'll be having 300 entries, right? For the same stock.
Sir, any other suggestion?
Second, you can go for, can you go for the next?
What, sir?
Next.
Hello. Yes,
Can
sir.
you go for the next slides?
Algorithms.
Go for the next one. Next. Okay. Why you have selected this all the parameters in your system for comparison?
Yeah.
Any justification? Hello.
Hi, yes, sir.
Yeah, any justification generally lasts for our use in majority of that ML or DL related algorithm. May I know why you have selected so many parameters for the performance measurement?
I can't understand.
Generally, go back to that slide number 12. Yeah, generally in ML or DL algorithm and comparison, right? Accuracy, precision, recall, and reference code are measured, right? So may I know the reason why you use all this 10 parameters? That's it. A single question. Okay, not an issue. Thank you.
Thank you for your presentation, sir.
Thank you.
Moving on next, I'd like to call Mr. Anish Kaleru for his paper titled Utilizing Object Detection and Lane Assistance to Optimize Visibility in Foggy Conditions, a review paper. Sir, can you please start with your presentation?
Yeah, am I audible?
Yes, sir.
Yeah, just a moment. Is my screen visible?
Yes.
I'm sorry about this. Yeah, so good morning, everyone. Good morning, sir, and my fellow presenters. So I'm Anish, and I will be presenting a review paper titled Utilizing Object Detection and Lane Assistance to Optimize Visibility in Foggy Conditions. So let us get into the agenda. So this is the subtopics we are going to cover today. So coming to the abstract, so foggy weather significantly reduces road visibility, so which leads to severe accidents. So our review explores the role of deep learning and computer vision in tackling this challenge. So we analyze the application of various models such as conditional GANs, single shot multi-box detectors, and AOD, which stands for all-in-one defogging network, along with YOLO. So all these models gives us a deep perspective of how to tackle object detection and lane assistance in adverse weather conditions. So coming to the introduction, as we've seen in 2021 alone, the overall road accidents in India has resulted in 13,000 deaths and 25,000 injuries. So in such cases, when there is immense fog in the road, drivers have obviously, have to depend on hand signals and visibility, and even the lanes are also not visible clearly as they are covered by the fog. So therefore, we've thought of introducing, a robust object detection and lane assistance model, that can identify hazards and objects for efficient assistance for the drivers. So let us go dive into the literature survey. Coming to the literature survey, we've divided this review paper into three main segments. One is the object detection approach, which discusses about the entire object detection models. So coming to the first paper, this paper utilizes YOLO V5 and FEM, known as a feature enhancement model. So these feature enhancement model tries to capture is useful for feature extractions. So this is useful for fast object detections. So in these models, the attention mechanisms offer a good balance between accuracy and speed. So the main disadvantage is these models struggle with camouflage objects and don't perform so well in adverse weather conditions. And the second one is AODS CL YOLO. So this is an extension of YOLO, and this uses a cross-partial segmentation module. So the main motto of this model is to defog the image using a channel pixel attention. So what the channel pixel attention does is it defogs the image according to the channel wise, namely RGB, or if the image is a grayscale image, then it defogs the image according to that. And the disadvantage with this is it is limited and it relies on synthetic data set. So the thing with synthetic data set, it tries to imitate a real world image, but it's not so accurate. And coming to the third one is end-to-end dehazing network. So this offers a robust detection because it consists of two decoders. That is one for dehazing a dense haze and a light haze. So this model is slightly computationally intensive due to its model complexity because it has two decoders. And then moving on to the lane assistance approach. So in this lane assistance approach, we have the FIS, known as the fuzzy inference system, and the carnage detection. So this model is very good for various weather conditions, and but the main disadvantage is it lacks real-time lane tracking improvement. And the next one is a ransack algorithm. So ransack basically stands for random sample algorithm. So the advantage for this algorithm is it is a robust detection algorithm for lane assistance, but struggles with immediate changes in weather patterns. And the third one is LaneNet, and it improves adaptability and real-time feasibility in fast driving. So the main thing with LaneNet is it is highly computational intensive, so it might not be adaptable for real-time purposes. And the last one is feature extraction and warning algorithm. So this algorithm, apart from object detection and lane assistance, this also provides lane departure warning. So coming to the next one is a combined object detection and lane assistance approach. So in this approach, a domain adaptive dehazing is used for dehazing, improving dehazing abilities. So the disadvantage is across weather patterns, it is limited and it is resource intensive. So the main thing we see is many models are highly computational, or they don't tend to work on other patterns. So one thing we've observed through our research is YOLO is being used across many applications. So why YOLO? We discussed the topic that why YOLO is more efficient. So one thing is when you tend to use these models in real life applications, what you expect is better reaction times. So the main reason behind YOLO's popularity is it is it has very high accuracy, and the speed is also very high. Approximately, it has an impressive speed of 45 frames per second, which is the highest in its segment. And basically, this is achieved through the module known as a path aggression network, which is part of YOLO's FPN architecture. So what this module does is it is aimed to improve high information flow between layers. So it combines low-level details and high-level details, hence the speed and detection capability of YOLO. So coming to the result analysis, So first we dive into the result analysis for lane assistance models. So these are the different lane assistance models comparing to the accuracy. And we observe that it is coming to the canny edge detection. It has the highest accuracy of 98%, and followed by the hue transform, which is a mathematical transform application using for detecting lanes. So it comes second, just below the canny edge detection. So the ransack and VGG16 have lower detection capabilities. And coming to the object detection comparison, we can see that CL YOLO, we have taken a precision and MAP into consideration as the parameters. So as you can see, CL YOLO has the highest precision in this segment, whereas end-to-end dehazing network, I mean EODNet, performs well in both the segments. So the proposed enhancements for these models would be to achieve real-time processing. We would like to utilize AODNet. Because why AODNet is because this is a single pass dehazer. So this is a lightweight architecture, basically good for real-time detection, and along with YOLO and efficient DET. So efficient DET is slightly computationally costlier than YOLO, but we would try to implement it for better results. And for additional lane assistance, as you have seen, canny edge detection is the best in its segment, along with hue transform. So because it enhances edge visibility, and along with these models, it is crucial to note that our application deals with the real-time vision data. So the data has to be processed within the vehicle itself. The main motto of this project or this review is to study the feasibility of this model in an ADAS system, which is an advanced driver assistance system. So with the help of that, we ensure to, efficiently advise the driver to drive in an efficient manner. Yeah, thank you. Any questions, please do ask.
Good, sir.
Thank you for the presentation, sir. Moving on next, I'd like to call Mr. Yoga Sridhar Reddy for his paper titled Veda, Visual Extraction and Decryption of Ancient Script. Sir, please can you start with your presentation?
Yes, ma'am. Is it visible, ma'am? Hello.
Yes, sir.
Yes, sir.
Yeah.
Yes, yes.
Good morning, all. I am Yoga Sridhar Reddy Kakanuru, currently pursuing BTech final year in a computer science stream from SRM University. Today, we are going to present our paper titled Veda, Visual Extraction and Decryption of Ancient Scripts. When it comes to the abstract, India is a country with very rich ancient historical legacy. It preserved vast cultural and historical knowledge through stone inscriptions. Mostly, we're gonna see these stone inscriptions almost all in every temples in India. Extracting text from ancient stone inscriptions and then translating it into a language, like into a modern Indian language, which is understandable by everyone, is a bit of challenging task because that particular script varies or changes with time, and then natural degradation of stones will occur, and then the surfaces of the stones might get degraded, so that we can't able to recognize that particular script through our naked eye. So basically, our idea is to build a model which can extract the text from these stone inscriptions, which were written basically in Telugu language, and then translating into any other modern Indian languages. Basically, our model is a integrated model which consists of RCNN and Tesseract OCR, which is a region-based convolution neural network, and then Tesseract OCR. Uh, our integrated model is trained on a custom dataset of about 30,000 labeled images. It is a dataset of 30,000 images. It is a Telugu script which comprises of Achulu, Hallulu, and Ottulu. Achulu can be considered as vowels in English, and Hallulu can be considered as consonants in English. We have got an accuracy of 96% in detection of character recognition. And then the text which is extracted from these images is basically ultimately translated into any other Indian language using API based translation modules like Google Translation API, like that. Then when it comes to introduction, our project mainly focuses on ancient Telugu stone inscriptions into modern languages using some advanced character recognition techniques. We are already having like traditional OCR systems. They will also work fine with the printed text, but when it comes to the handwritten text, it will struggle a bit with the complex and degraded nature of that particular stone inscription. So for that, contrasting featured images can be done by using advanced OCR technologies. So our project basically bridges the gap between this and develops a specialized RCNN algorithm that can effectively recognize and translate characters from these ancient inscriptions. Our project's objectives is basically we want to recognize the text which is on the stones, which has been written by our ancestors. We want to get accurate results, and then we want to optimize the model by using some deep learning techniques, and then we want to translate the script into the language of user's choice. Our main objective is to preserve the cultural knowledge and our rich Indian heritage, which might help the future kids to understand about our India in a much better way. Our related work is basically like traditional models such as support vector machines or CNNs, convolution neural networks, recurrent neural networks are basically can be used for printed text, but can be helpful for sequential character recognition. But in terms of handwritten text, they won't give accurate results. So when it comes to the accurate, recent advancements, we have text snake, CRNN, and master, which can also help us to recognize the text from the degraded stone images. But this will require a lot amount of training with a large labeled data sets, and it requires large high computational cost as well. So there are some models like YOLO and East models as well. They also give good results, but it requires more amount of training. So when it comes to all this, the comparison, it is best to use RCNN and with Tesseract OCR, which is a suitable approach for extracting Telugu scripts from ancient stone inscriptions. This is our proposed methodology. Basically, we're gonna give an input image as a stone inscripted image. First process is like data pre-processing. The pre-processing step is one of the important step in extracting the text from stone inscription image. It is basically helps us to resize the images like 224 into 224, which introduces uniformity over the data set. And then we will try to convert these images into tensors, which helps us to apply some deep learning techniques over the data set. And then we will try to define the batch size of the images, which is suitable for our training, and then splitting data into training and testing. And then we'll try to use our integrated model, that is RCNN plus Tesseract OCR, and then model training. We'll try to set the hyper parameters like defining batch size, training rate, etc. Cross entropy is the last function we have selected here. Adam optimizer helps us to optimize the weights that has been put over the data set. And then we'll try to evaluate the testing data and plot the loss and accuracy curves. And then we'll try to use the Google Translation API module to get translate into the language of user's choice. This is RCNN architecture. If we give an input image like this, it is going to plot some bounded rectangles over the image which is having text. Will be converted into three features. That the image which is not having any text can be discarded, and the image which is having some text will be considered as a separate image, and the image with some noise. Then this is the original image, and we after pre-processing we gonna get an image like this by using some Gaussian filters, etc. Then this is basically our application screenshot. This is basically a output graph. Here, x-axis represents training epochs, and y-axis represents the accuracy. And orange curve basically explains about the training epochs. it is almost touching 1, so it is training on a better rate. There is a small fluctuating over the curve because it is showing some small variation in terms of training, and in blue curve it is declining, so it is basically represents the overfitting of the model, so which we are going to work on as the future scope of the project to get accurate results. Basically, when it comes to conclusion and future work, uh, our project sought to create a system for extracting the text from ancient Telugu stone inscriptions and then translating them into Indian local languages and evaluate the efficiency. We identified that the integration of RCNN with Tesseract OCR efficiently identifies and extracts text characters from ancient stone inscriptions, then translating the extracted Telugu text into Indian languages. This work not only bridges linguistic and cultural gaps, but also contributes to the preservation of our cultural heritage. Despite the promising results, the integration of RCNN with Tesseract OCR has certain limitations. The approach is computationally intensive, particularly during the training phase, and occasionally struggles with extremely degraded and overlapping stone inscriptions. Like if an image which is degraded, it is difficult to recognize the text from that particular image. Future work will focus on addressing these challenges by using some advanced pre-processing techniques and exploring hybrid models that integrate transformer-based architectures, which would eventually give us an accurate results. Thank you, sir. That's it from our side. Sir, any queries?
Yeah. So which difficulties you faced during this processes, pre-processing especially?
Yes, sir. So basically, we try to use a traditional OCR, sir, as a base models. Then we got to know it is working for fine with the printed text, sir. But when it comes to the handwritten text, which looks like this, which eventually looks like this, it is becoming difficult to recognize the text, sir. So we tried to use Gaussian filters and canny detection techniques to basically pre-process the text and give us accurate results, sir. Then we used RCNN model, which helped us in a very better way to recognize the text properly, and it is of less computational cost as well.
Okay. One more thing. Can you go to your proposed system?
Yes, sir.
Yeah. Now, let's say you'll be having some scripts written in the Telugu, right? This is my question as a curiosity. So let's say you are resizing the images in the resolution of 224 cross 224, right?
Yes, sir.
Now, let's say there'll be some scripts or some characters in the Telugu. It'll be like Q and O. So it'll be minor fluctuation with it. And if you are downsizing that thing, right? Will it a similar kind of Q will become O, or similar kind of thing happen in your Telugu script? How you're, if it is yes, then how you're resolving that?
Sir, can you please repeat it again?
For example, I'm writing Q, right?
Yes.
Now, if you are downsizing that thing, right? It'll be scaled down to a similar, it will look like similar to O, character O. So there will be some similar script in the Telugu also.
Sir, yeah, sir. In Telugu also it is similar to similar like, but we have trained on over 30,000 data sets, sir. So that it is going to differentiate the image, sir. Even if we are giving Q and O after downsizing the image, it is going to check over the data set. Like we have given some 1,000 images for each alphabet, sir. So it is going to pre-process all the 1,000 images and gonna differentiate between the images, sir. And it will differentiate Q and O.
Good, good.
Any other questions, sir?
No.
Thank you, sir.
Thank you.
Thank you for your presentation, sir.
Yes.
So I sincerely thank all our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I'll also like to thank our session chair, This is a token of appreciation on behalf of the team SmartCom 2025 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence.
Thank you.
Now, I kindly request everyone to switch on their cameras for a quick snapshot. Thank you, everyone. Have a nice day.
Thank you.